Okay, this is the last talk for this session. This is what I'm trying to do is to share our research and practices on real-time impact-based tsunami-focused facility to contribute to early warnings for all and tsunami ready. So I'm Shunichi Koshimura. I'm a Deputy Director of the International Research Institute, Disaster Science, Tohoku University. I'm also working as a CTO of the RTi-cast. That is a Tohoku University-based startup to offer tsunami-focused services. So it's great to say to you that the RTi-cast was officially approved by JMA in March 2024 as a unique private-based tsunami-focused provider. So the motivation of our efforts is the 2011 Great East Japan Earthquake tsunami that caused inundation, extensive inundation of 161 square kilometers. That the highest run-up was 40 meters above sea level, causing more than 18,000 fatalities. That was about 3% of the population in the inundation zone. And then 120,000 buildings destroyed. And then the consequences of these as the economic loss was up to 25 trillion Japanese yen. That was a quarter of annual budget of Japan. So having this catastrophe, the question is how we can recover or reduce the losses and then recover quickly. That is the resilience. So to support the resilience, that's what we are trying to do. So thinking about the tsunami warning information, so I'm showing two examples. On the left, that's the tsunami warning message from National Weather Service of the United States. And on the right, that is the tsunami warning message from JMA. So those are very similar based on the forecast of the maximum tsunami height on the coast. However, watching the video in the Great East Japan Earthquake, the Tohoku tsunami, so we wanted to know that how extensive tsunami penetrate inland, and then that tsunami penetration would cause how much of damages. So that is our questions. So to do that, we are doing the services of the Tsunami-cast based on the real-time impact-based tsunami-focused system. We, Tohoku University with the partners, developed a unique end-to-end impact-based tsunami-focused system with full operational capability using a supercomputer of Tohoku University. So that is the reason why we established the RTi-cast that provides the real-time tsunami inundation and damage-focused products. We call that services the Tsunami-cast for the responses of the government organizations and commercial clients, like insurance and the transportation industries. So that's what we do to provide tsunami-focused services at Tsunami-cast. Now, what's in operational in Japan? We are using the GNSS data to determine the tsunami source model. I'm showing the animation on the right, how we determine the tsunami source model with using the GeoNet data, the GPS crustal movement measurement. So with that, we run the simulation of the inundation on the left, using the supercomputer to run the simulation in real time. So, and also having the focused result of the tsunami inundation, especially on tsunami inundation depth, we applied the tsunami fragility curves to quantitatively estimate the building damage for the wooden houses or others, like steel or reinforced concrete structures. So with that, that makes it as possible to make the tsunami inundation and the damage focused fully operational in Japan. So this is the value of the Tsunami-cast to support the resilience. In other words, to reduce the loss and recover quickly. So we are trying to provide the information on how extensive does the tsunami penetrate inland, or in other words, where the safe place is, and how many peoples are exposed, and how many infrastructures are damaged, how extensive disaster relief activity should be deployed, and how much losses are. So I believe that those are the very critical questions in the aftermath of a disaster occurs. So that is the reason why I'm saying this is a value of the Tsunami-cast to support the resilience of disaster responders and community. So now it's quite nationwide. So we started the focus services in 2018. That's the showing on the map on the Nankai Trough region, and then have been expanding its focused region year by year. And now we are working on the development for the Japan Sea area. And then 2026, I think we complete to make that focus system fully nationwide for Cabinet Office of Japan and for the prefecture government. So this is that's the one we had with the computational capability of the tsunami to run the tsunami simulation using a supercomputer. However, when we think of expanding this capability to the other part of the world, I think we need more resources on the computational capability. So that is why we try to expand this to run on the other systems, like a GPU. So this is showing the performance of the Tsunami-cast to the 6-hour forecast with 10-meter resolution. So you can see that in the middle, this part. So this is the performance using the supercomputer of Tohoku University, and then using the GPU of the NVIDIA A100 and H100. So you can see that those performances are pretty good to complete the 6-hour forecast within very high spatial resolutions at 10 meter within like a 5 minutes. So that's what we have achieved. And then this means that we can expand this capability to the other part of the world using the GPU on the cloud system. So let me show you some Tsunami-cast products. The first one is the tsunami arrival time. In general, the tsunami arrival time means the time of tsunami arrival on the coast. But we do the inundation forecast. So that is the reason why we can provide this kind of map to show where on the land will be starting the inundation. So this is the one product of this to show the tsunami arrival time on land. And the next is the inundation depth with the extent of inundation. So the users can add their own information, their own data, like critical facilities. So this is one example to show that how the users, actually the red pins are the evacuation buildings. So the users can know that which buildings will be inundated or not, and then how many people are evacuating over each of the buildings. And then it's good to know how many people are isolated waiting for the rescue, or how many people are saved. So I believe that those are very important information for the responders. And also we estimate the building damage and then exposed populations. So this is some examples of the Tsunami-cast product to the users to support the resilience. So towards the global real-time impact-based tsunami focus facility, I think we need more collaborators. For example, the rapid determination of the tsunami source model. I think this is a key part of the functionality of the forecast. So I think we have the several levels of the technologies. The first one is just simply using the rectangular fault model with the epicenters and magnitude, and then CMT solutions, GNSS-based solutions, or offshore data assimilations. So based on what we have for the target region, I think we can choose one of these as a best effort of the tsunami source model to use for the focus system. The second is the urgent compute capability. So far, we are working on developing this on the supercomputer of Tohoku University, but now we got to have a new partnership with the AWS. So I will talk about this later. And then the third is generating mapping products. So all the users have the web browsers. So what we are trying to do is to disseminate the mapping product with the cloud-based GIS system, like ArcGIS Online, to disseminate the mapping product on the web. So I'm talking about the new partnership with the AWS. So we have the new partnership with AWS. So I'm showing the supporting message from the AWS.
I would like to congratulate Professor Koshimura on his presentation at Global Tsunami Symposium. AWS and Tohoku University are currently building a collaboration in the field of the disaster and resilience. Professor Koshimura has visited our headquarters in Seattle and has provided us with many valuable things. Thank you for choosing AWS as a partner. I hope that this collaboration will contribute to solving global challenges in the disaster and resilience. Thank you.
Actually, Usami-san of the AWS provided this message for my presentation at the UNESCO Global Tsunami Symposium in November last year. But I think this is a great message for us to show the new partnership. So I think it's, in this sense, I think we are ready to expand the capability of the impact-based tsunami forecast to the other part of the world. So the Tsunami-cast product for the global agendas. So this is the standard forecast product for us, like tsunami arrival time on land, inundation depth, building damage, exposed population. So I believe that those are contributing the two global agendas, like tsunami ready and then early warnings for all. For example, the tsunami ready, I think they are required the tsunami hazard assessment data, tsunami evacuation plan, emergency response plan. And then early warnings for all, the tsunami inundation forecasting, and then dissemination and communication and emergency response. So that is what we are trying to do. So we really wanted to contribute those two global agendas through our activities of the Tsunami-cast. So this is the last one. So what we really propose is the real-time impact-based tsunami forecast facility to share with the users of the world. So of course that we'd like to contribute the Sendai framework for disaster risk reduction, especially one of the four priority of actions, like investing in disaster risk reduction for resilience, to promote the cooperation with the private sector to develop the new products and services to help accelerate the tsunami ready. And also, I'd like to introduce that the good message from Dr. Karanawati, the head of BMKG. She was telling us that the importance to endorse the private sectors to accelerate the achievements of early warnings for all. So I believe that there's lots of things work together with the colleagues of all the world, and I really hope that we can contribute to the global agendas, tsunami ready and early warnings for all, to the end of by the end of 2030 or 2027. So that's all. Thank you for your kind attention.